Seems to be working on it. Is there any audio? Is there any audio? Yeah, I mean, that's got such a delay on it. Cool. How do I see how many viewers I've got? How many viewers I've got? Seems to be working. Don't think it shows me. Okay. Probably open my laptop because it's going to get hot. Step out of the way. There we go. Right, what was I doing? Oh, that's screwed up on my screens. Lovely. Gives that 5 minutes to out. go. Right. Oh, no, they've gone again. Right, I think it's happy. Let's put that over there. That over there. This one I don't need. That one I do need. Go. That one I do need. Sorry, messing about my screens a bit here. They're all over the place. Right, there we go. Switch to the board. Okay, back up and running. Grand. Right, what am I doing? So, basically, I'm routing this PCB out and connecting the connectors together. So, at the moment, what I've got is all of these switches down the bottom here. I need to route all of these cables through. These are all on RB2 to 5. And I also need to get RB0 and RB1 from there. So I need to get all of the RBs from here. So RB goes from there up to 5, which is that one. So these don't need to be too big. They need to go on the bottom layer, which is blue. Okay. So RB0. Let's try and get it as close to here as possible. Oh, why is RB0 needed? Okay, RB0 is also needed here. Okay, I might be able to do something clever with that then. Okay. Oh, I didn't know very good. Why are you wanting to go over there? Come straight down. There we go. Right. So the RB0, I will for that one. Let's put, if I go to there and put a via in. There we go. Route RB0. And then I want to go back to the bottom layer. And this needs all the way to here. So, and then I'll just do the same. Top layer, that puts in a via. And there we go. Cool, that's RB0. And I need to do the same with RB1. Now, where does RB1 go to? So here, that's RB1. RB0 is that one. Okay, so just RB0 for that one. Down here is RB1 is needed for that pad. So I'm going to have to put something in there. Fine. So let's grab RB1. In the bottom layer. Go. So that needs to come down to, okay, RB1 is also needed there. So if I can get it in there, I might need to move some things around. Let's see how close I can get it. Oh, that didn't actually change. There we go. Oh, I can't get one in there. I need to move that 5-volt out of the way to make space. Okay. Let's reroute that 5-volt on the top layer. Just want to make some space for that via. Grand, there we go. Okay, so if I now do that, yeah, And if I change it to the top layer, I should get that, and it will fit in there. Lovely. That can go to there, and that can go to there. Grand. And that's RB0 and RB1. Now I need to get 2, 3, 4, 2, 3, 4, and 5 all the way down there as well. So, yeah, layer RB2. Gotta get it past that via. Am I gonna have enough room? I should do. And I can go all the way down to that pad there, so I don't need to make a via. Perfect. Okay. That's 2, 3. Try and get it as close to that one as possible. Ooh, this is going very. Performance of my laptop is obviously being kicked a bit by OBS. Now I've got that 5-volt rail there, and I need to get 4 and 5. So let's see if I can move that. Oh, I don't like that. Let's see if I can move that over to here somewhere. Let's go around. I know it's on the bottom layer, but I want to get it somewhere there so that it's kind of not underneath the signals. Well, that's ground, so it doesn't really matter. That's fine. Yeah. Okay, fine. Now, can I get... I need to get RB5 over to there and RB4. I might be able to get RB4 to squeeze down the middle of these, but I doubt I'm going to get 4 and 5 to get to there. So can I... Might have to via it again, change to red, to the top layer, and then move into that bit. It's not pretty. What else can I do? Let's see. Let's try it. So, bottom layer 4. Come all the way down here. And let's get it in the middle of those. No, okay. I'll do the manipulation afterwards. 4. Let's just move that. I want to get that a little bit in the middle if I can. Yeah. Perfect. Just notice that 5-volt rail is too close to that. Don't want that. Grand. Good, that looks good. Right, so that 5 I've got to get from there. Okay. So it's got to come all the way from that RB5 there. Let's get it down to there at least. And then... let's see, can I squeeze through there maybe? Does that 3.3 volt need to be? Yeah, it does need to be fairly thick because of the amount of current it's going to be carrying for the 3.3 volt. Let's see if it fits. Let's chuck that. Let's not get it near the silk screen. Fire. Let's see. Yeah. All right. That'll ding ding do. There we go. Cool. So that's 5-volt and 5-volt. That's fine. I could connect that through there. What's going on there? Why are you two? Are you the wrong way around? Oh no, you're just... Okay, so I need to connect those to those two. That looks fairly simple. That VCC line needs to connect to there, so I could go around that way and around that way. How have I done it on this? I've done it where... Yeah, and I've gone around that way. Fine. Let's do the same on this one. So, I2C SCL. I want to go around. So let's go straight out of there. Around. And in. Cool. SDA wants to do the same. Let's get that looking a bit nicer there. Good. The I squared C VCC line. These are just for the they're just resistors, so they don't need high amount of current. They're 10Ks anyway, so they're going to be in the very small, not even milliamp range. So that's good, and I can just go straight to there. Let's get it coming out neat. Perfect. That looks good. Yeah, that's ground. That's fine. I'm going to do like a big plane for the ground, so I'm not too worried about those. Good, good, good. Ground, ground, fine. Right. Spine needs to be connected. So let's see. We've got SPI, master and slave out. What have I done with this one? Can I move this 5-volt around a little bit? Oh, no, that one. Let's see if I can make some room in here. Can I get the SPI VCC line, which is this one? No. Okay. So that's in the middle of a transistor. So no, I've not got enough room to do that. And the 5-volt. Okay. Fine. Let's sacrifice the 5-volt for a minute. Yeah, that one and that one, because by the looks of it, I can route around the outside anyway. Let's get rid of that. Nope, not that one. That one. Grand. So I want to do let's do the power first. So this is SPI VCC. It's going to go straight down. SPI VCC. And to this one. Okay. I want to put a bend in there. There we go. Grand. And now I need to get... Oh, that SPI VCC is right there. Okay, well, I can do CS and master and slave out that way, and then master out slave in can just come around this way, and clock can come around this way. I still need to connect those two. Now that ideally needs to be on the top because of this 3.3 volt on the bottom. What can I do there? Oh, what about if the SPI VCC, let's get that out of there. Second. Now that needs to be fairly chunky going that way, so let's change the width to 24 and go to there. And then if I can do a smaller one, 0.1, let's go nice and neat. Oh no, don't like that. Don't do that. That's better. I can go straight to there. Lovely. Great. So that gets rid of that. And all of the data lines can go around the outside. So, top one can go around the outside of this. Let's get this looking nice and neat. Let's go around here. Clock. Oh, I don't like the fact that that doesn't have a thing in it. That's better. I don't like right angles when it comes to routing wires. Let's get that looking neat. That doesn't look neat. That's fine. We'll fix it in a minute. Something like that. Cool. Master in, slave out. No. A bit lighter, please. Let's go to there. Oh, that looks ugly. Do that again. Let's go to there. That's better. Beautiful. And CS. straight across. YOLO. Cool. I'm just happy with that. That looks fine. Can't say anything. Yeah, that's a decent power line. That's good. This is all just pull-up stuff anyway, so that's fine. Don't need to worry about that. Oh, RA5. Hello. That's... Ooh, okay. That looks challenging. RA5 has got to come from this pin here on the pick all the way to there on that transistor. And I've got a lot of overlapping signals as it is. So if I was to come here on the bottom layer in blue, yes, and then if I got to there, I'm going to have to change this all over the place. It's only the CS line for the SPI, so it's not too much of a problem. If it was a bit more high speed, it might be a bit of a problem blasting around all the different layers and stuff. So this one's just going to have to see how far it goes. It is a one-off signal. It's not like a big bus. So it's going to have to go blue to there. And then does it make sense to go... Does it make sense to stay blue as much as I can? Oh, actually, I've just seen a route that's possible. What about, let's just move these across a little bit, like to there. Let's pull that right down. Okay, now I'd possibly do this. So, what I'm planning on doing is opening up a bit of a pocket up here for that signal. If I can get away with as minimum amount of wires as possible, great. What are you doing? There we go. Cool. All right, keep coming. Oh, what are you doing? Try again. There we go. Okay. Come on. Go. That's what I want you to do. Don't like that pinch point up there. Let's zoom in on this so I can see what I'm doing. I could bring these right, actually. Thinking about it. Let's bring them right down and make as big of a pocket as we can get. There we go. Yeah, that's better. That gets rid of that sort of pinch point. Let's get rid of that right angle there. Cool. Now let's see if that C will do something better than that. Ugh. Okay. Is that in line? No, I don't like that. Let's see if we can get that to line up with better. Sometimes when you do it, there we go. See, it grabs it like that. So they're together now. So now when I grab that, it's one signal. There we go. Or one signal. It's the same signal, but it's just not in the way. Now I want to make a pocket here, so that basically I can go top layer to there, bottom layer, all the way across all these red ones. So what I need to do is see if I can open up. Oh, my camera's just turned off. Is that my camera turning off? I'll have to look at that and figure out why that happens. I think that's a big enough pocket for a wire. Don't think I can get any bigger than that. I could move these down a little bit, I suppose. Let's have a go. Do I need to do any other bits? Doesn't look like it. Let's see if I can just neaten this up. Go. Oh, that gets rid of that that pinch point I had on there anyway, so that's nice. Can I get that to the point where it's a... That's okay. What I don't want is anything less than 90 degrees on these bits. 90 degrees is fine, unless it wasn't, but it just means that there's no like pinch point. Don't like the pinch point. It doesn't make it easier for manufacturing, and it also can cause signal issues. Okay, let's get them looking nice and neat. There we go. B5, come down. Now, B5 looks quite nice up there. So I might leave that as it is. Does that one? No, that one. It might be that that dictates how far down I go. I think it will. Although I like that RB2 down the bottom there. Which one do I want to do? Which one do I want to do? I'm trying to make a big enough pocket, so we'll go with the bottom one is taking the stance there of which one I want to do. Come on. There we go. Right, so I need to just sort out this because I don't like this. Let's do... No, hang on. Why are you so fat? I don't like that. Let's get rid of that. Nope, nope, that one. There we go. And I need to sort out RB6 as well by the looks of it. Nope. Don't want any right angles if I can help it, please. That'll do. That'll ding dang do. Whilst I've just spotted that RB6, let's just neaten that up. If I can. Let's see if I can get it to grab. There we go. And come out something nice. We'll go and join RB7. There you go. In fact, actually, let's do that one close to there. Let's do, yeah, RB7, RB6. There we go. Those two are the programming lines that go to this programming header over here. So they're kind of crucial to get right. Right, now I've got a nice big pocket. I've got a nice big pocket there. Even better, because that is less than 90 degrees. So I need to actually... Yeah, that's cool. Hello RC4, you don't look healthy. That looks better. RC5 doesn't look healthy. Let's fix RC5. There, looks good. I thought I said RC5 for a second. There we go. Cool. All these need sorting out. Cool. Yep. Go to there. RD6. To there. And then this one to... Come on. You know, there. That's it. Perfect. Okay. Right, now I've got this pocket up here, so I just need to move all of these lines here to here. Then hopefully I can get... Where is it? RA5, that was it, wasn't it? That's what we're trying to get over to there. RA5 all the way over to there. So, now how am I going to get? So I can get from there on the top layer all the way to there, change to blue on the bottom layer, all the way to here, I could follow this on the blue, change to top layer there, bang, RA7. Perfect. That looks good. So, top layer. RA7. Straight out. Follow to there. Nice. Bottom layer. Create a via, changes to the bottom layer. And then we can come straight down, almost, let's get out of the way of the USB, to there. Yep, and then we change to the top. Nope. Okay, I think I done it. Right, now it's red, where we can go to there, and we can go to there. Here we go. And that's just the CS line for the SPI bus. Simple. What's left? I think. What are you? That's ground. I'm not worried about ground or anything because I'm going to do a big floodplain later for the ground. I'm just looking to see the 5 volt. What am I going to do about the 5 volt? Do I want to route the 5 volt or do I want to? I guess I have routed it. What are you? What's that? RB0. Oh, hello. RB0. Now RB. Oh, I thought I did the route for that. Oh, that's probably the 5 volt line. That one. Yes, it is. Fine. So. What am I doing about that 5 volt there? Because that's where I removed the 5 volt there. So that I can make room for this SPI VCC. What do I want to do there? How do I want to get that through? So that's connected to that. That's fine. But I need to get that to connect to there. So 5 volt. Okay, or I can ignore that one for now and just connect that one to there. Top layer, 5 volt, straight out, along, back in, bang. Cool. And then this 5 volt can just connect to that 5 volt there. Simple. Ground, 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 ground. That's fine. That's fine. Ground, yeah. So that 5 volt, is that actually connected to? Somehow, because that's the 5 volt for the pick. Oh, I could just connect to that one. Nice, obvious one. Let's get a nice fat track for that. On the blue line, please, on the bottom. 5 volts, straight across. Let's get it coming out nice. Up and over. And in. Lovely. Great. That's the 5 volt there, which... Where's that one wanting to go? Oh, that's that. There's a resistor there that needs 5 volt. Okay, that's nice and easy. That is only a pull-up, so that doesn't need to be a big fat cable. Cable? Track? See, when I come to do the... Oh, hello, Master Clear. How am I going to get you through to there? Well, to be fair, actually, what I could do is just move this switch down a bit here. Is it sensible to move that? What color do I want that to be? What color do I want that to be? Oh, actually, if I move that out to here, let's get rid of those ugly tracks. Nope, that one, and that one that I've just done. And then I can top layer. Yeah, it doesn't need to be a big fat one for master clear. There we go. Then this master clear can... What do I want to do there? I'll just put it on the bottom layer. Can I get away with it on the top? Don't think so because of these two programming lines. No, fine. It's going to have to go on the bottom. Matters not really. It's only a... To be fair, the crucial one, that is this one coming from the resistor. So that's fine. Let me just do this. How are you doing? I'm good. Oh, hang on.
Are you recording?
I'm live.
Sorry.
That's okay, don't worry.
Yeah.
Sorry. Yeah, sorry, there's nobody watching it anyway.
Are you recording it?
No. Sorry, I could do with having a button that just gives me no camera. Oh. I want to go from there. Yeah, let's get it inside that silk screen. Onto the top layer. There we go. Lovely. That's master clear. Good. That's all ground. That's all ground. That's 5V as well. How's that 5V going to get in there? The V in. So along this top, I've got power, ground, power, ground. How am I going to get that V in into there and over to there? That's going to be a challenge. Because obviously all of these go all the way through. Can I even get a V in under there? All the way around? Probably not. I don't really want to go underneath these if I can help it, because that's all communications. That's going to be a nice challenge. Oh, let's finish off that one. Boop. There we go. Maybe I should have done this red one the same as I've done this one. I think I will. I'm going to cut this track here. Oh, no, that one. I'm going to cut this track here. And I'm going to move this. And I'm going to go from here. No, don't move that to there. What I need to do is swap those two over. Come on, Mr. Via. There we go. I put Via there. Put that there. And I can go from here. Haha, gross. To there. Change that to there. Cool. And then that blue can come nice on here to there. Which means I've now got all of this area in red to be able to route potentially power and 5V, etc, etc. That master clear doesn't need to be that thick. Let's get rid of that. Let's use the paint roller. Width. Ding, ding, ding. Can I get away with getting that over there? No. Fine. Yep, that's okay. That's okay. Good. Which might give me a route to power on a red through here. It's got to come all the way down to here. God knows how I'm going to get the power up to that. Yeah, figure out. Nah. So what's that? That's the 5 volt. So this is the 5 volt for the programmer. So that can come from here. Simple. Let's put it on the top layer. Oh, that didn't change. There we go. Lovely. Let's go to there. To there and boop, onto there. That's fine. Now that 5 volt. How much power do I need for that? I'm going to make that a slightly thicker, actually. Let's undo that, because there are times, because this is the programming header, there are times that you can have the pick kit actually powering the whole circuit. So let's do that to there, and then just want to make that little bit there. Oops. Paint roller on the width. So could have just done that in the settings for that track, but whatever. That's fine. That's just a pull up. That doesn't need any power really. Not big power. Ground, 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 ground. Right. Let's see if I can get that V in line all the way. I've just done that on the top layer. Now, it would be great if I didn't put the V in line going through wires, because wires are small. I have to make big wires. And doesn't look like I can easily get away with using the bottom track because of master clear and those programming lines. So let's, what should we want to do here? We have a nice big yellow line going all the way across, saying I need to connect to here as well. No. What do I want to do? What do I want to do? What do I want to do? I think I'm just going to have to put a whacking great big wire in there. But then I'm going to change the blue, and I'm going to go to there and have to change again because of these two. Fine. In that case, how about if you two what was I going to do? I was going to do red all the way to there. Okay, what about if you two then? Move. Let's put that one there. That's, oh, hang on, they're programming lines. If I can help it, I don't want those to go anywhere near that. The end. Oh, not in line with it anyway. If they cross over, that's fine, because yeah, that's okay. Won't cause much of a problem. But if they are in parallel with a high current line, the high current line will give off a magnetic field, and the lines will basically run through that magnetic field, and that magnetic field then gets coupled by the wires. Don't want that. Oh. What do I want to do about that V in? So that 5-volt line, yeah, that has to really stay on the top because it's crossing right over this lot. However, that 5-volt line won't be taking as much current as that V line will be, because that V in line is going to be like powering motors and all this big stuff. Oh, it crosses right over the programming header. Okay. I think it'll be okay. But I think I might put this 5-volt line. No, because it's got to cross over those two blues as well. Where am I going to put it? Where am I going to put it? Where am I going to put it? If I... Okay. These two come right out over here. Give me some room. So I've got a lot of silk screen around this area as well, so putting in wires and stuff is not ideal. But I might be able to open up a pocket. Oh, no. I'll do something like that. I can open up a pocket there. Fine. So if I then go cut that and there, here to here. Look how small that wire is. Right. That. Surface area, that, to be fair. Mind you, the problem is the thick, because it's got to carry power through there. It's not so much the size of the pad, but the thickness of the wire wall is not ideal. It would be good if that was actually like a pin on something. Because then the pin can carry the actual current. Can I get that 5-volt to go somewhere else? So that's got to come down to there. And then, hang on. Get rid of that. Right. The V-in's got to come all the way down and connect to this pad here. Actually, it's got to connect to this one here, because this is all of the reverse polarity protection stuff. So it's got to come down to there. God knows what's going on there. That's gross. There we go. That's got to come down there. Oh, the 5-volt is this one, ideally on the other side of this. So if I could get a V in to come down to here, 5-volt is on the other side. But at least a pin. It's that pin there. Ideally, I want to connect to, because this is a link, physical link, that allows you to take it off and measure the current on the 5-volt. So ideally, that 5-volt wants to be on the on that side of the programmer. can I move these blue lines around a little bit to make some room in there? Because then technically that 5V can go what can it do? It can be red. That one's got to come down there and connect to that. That one's got to come down there and connect to that. I don't think it's so much for a problem. It's not a big amount of current. Or is it? Or is it? Do I want to put the 5V through a wire? Ideally, no. What do I want to do? What do I want to do? It'll be fine. It'll be fine. From there, change to the bottom. Let's do that, and then what I'm going to do is I'm just going to play with this size of this. So, diameter. Let's see what happens when I... Yeah. The bigger... If I make the drill size the same size as like one of these, push come to shove, I could stick a pin in it. Stick a pin in it. Which means I want the roundness to be, what's that? That's 3,925. Looks about right. Let's make that a little bit bigger. 5. Yeah, that looks sensible. Alright, I'm happy with that. Push come to shove, I can stick a pin in it, like a component leg or something. Now what would be good, is all of these hole sizes were the same diameter. Because when it comes to, when we put it on the PCB making machine, it means it's only got to do one. But there's loads of wires and things. All of these wires are going to be the same size. Oh, I need to change the size on the pick as well. I think. That's going to be a bit all over the place, isn't it? Why not make it the same diameter as these? So, this here. Can I see what the diameter of that is? What am I in first? Inches. Footprint. Let's have a look. Huh. So the pad. Change that to inches. Drill size is 0.044. Okay. So on here. No, don't move. Drill 0.0. Can I type it in? Okay. And then let's... Does that look weird? That's not the same diameter as that, is it? Can't be. Come on. Shift. Why are you not on move anymore? Right. Yeah. Same diameter. Okay. Fine. I'd like the pad size to be bigger though. A bit more, considering that I'm no longer like... You got the thickness of that. I guess that's going to like half it's going to go that way, half it's going to go that way. I'd like that to be bigger. Nice. Yes. That looks good. That looks almost the same as that. Perfect. Right. So if that 5V line's good, this on the top layer. Let's go from that one. Can come straight down. Yeah, something like that. Straight down, and it's going to go into. Come on. Nope. God, it's really. OBS is really taking a hit on my processing ability. VN2. Oh, it's not labeled correctly. Oh, right. Hang on. So, it needs to be that one so that it's outside of the reverse polarity. So here, I need to change the name of this to VN2. Yep. 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 There we go. VN2. Yep. This one, VN2. And this one, VN2. Cool, that's better. Nice. Now this, I just want to get the bend off of the thing. There we go. That'll be fine. Right, so that's VN2 there. I think the rest of it is just ground, apart from this VN up here. Let's just connect these two together. Jazzy. Oh, what are you doing? Oh, that's why. I wasn't on 24. There we go. Yep. That one to there. That one to there. Cool. I think everything else is ground. That 5V isn't connected. That's nice and obvious. Let's do that. Don't like that pinch point there. I do. Yeah, cool. That's going to be nice and big with the actual. Yeah, it'll be fine. Let's just move that a bit. There we go. That's fine. Doesn't matter. Ground, 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 ground. All grounds, grounds. Ground, ground, ground. Shield, ground. Let's just move that via down because then there's some scope to get ground in there. Cool. That V in there. That's the problem. How am I going to get that V in? It's got to come all the way from the other corner of the board. Look at that. I love the way this ground here is not the same as that ground. Oh, it's 5V. That's why. What? Hang on. That 5V there is pointing all the way down to oh. What? not quite right with that little link there. Alright, yeah, so I need to make that 5-volt link. 2, 4. Straight out of there, straight into there. Does that satisfy that one? Yep, that looks all connected. So I think if I click on a signal, see it shows them all. That's pretty cool. Now because it shows them all, I can now check to make sure that all the 5 volts are doing what they're supposed to be doing. There's a 5 volt there, 5 volt there, 5 volt there, 5 volt there. These are all connected, yes. That's connected to that pull-up. That's connected to the programming header. Good, down here. All the 5 volt rail. This is the 3.3 volt rail. That's going to all the switches because they're all active low. So when you press it, oh, my camera's died again. How do I stop it? Camera dying. Figure that out. 5 volt, 5 volt, 5 volts. Okay, so the only challenge I've got then is that big voltage line there, all the way down to there. And I don't want to, if I can help it, go underneath this and like come this way, because this is all communication stuff. And there's going to be a slim chance of getting ground in there. I doubt I can get anything beyond the boundary outside, because these are lined up with the edge because there's a connector going on there. I don't want to go 4-layer because the prototyping thing that I'm using is only 2-layer. And I don't want to have to go 4-layer because it means I've got to order special PCBs and things. Could, because the thing is, got overlapping blues and reds here. Let's get rid of those. That's better. What do I want to do there? How am I going to get that V2 out of there? What if I opened a pocket here and went, so port D at the moment is only going to the LEDs, so I'm not too worried about if they induce current because it's going to get absorbed straight away by, you know, the LED. It's not going to cause a problem with the LED unless somebody's going to decide to use port D for something else, but I don't think it's much of a problem. And I don't think any of the communications buses, the RCs, don't think any of those use the D port, so that's okay. C port, they do. RC 4 and 5 are USB. which is not great because that really doesn't want to go near power. I could just take that connector out. Do I need a connector on both sides? Possibly not, and then I could separate out those a bit. I might just do that. I might just take that connector off and move these along a little bit. There is scope of potentially adding port E into here because port E isn't currently doing anything. Port E is sat there doing mount. Does mean enough to try and get port E out to there, which isn't impossible. Because it could do a similar sort of thing to what this line's done here. Try and cram 4. It come to there. 4 wires into there. And then I think I might just take that connector out and just move these along. I don't think it's needed. I think I'm going to have plenty of power here. Yeah, and even then I can make this track even thicker if I need to, because I could. It's not easy in here, and that's right next door to Master Clear. I don't think that's too much of a problem, because this resistor is pulling Master Clear high anyway. That isn't ideal. Isn't ideal that's right next door to Master Clear. Oh, in fact, I could run this. Can I move this a little bit close to the edge of the board? Okay. I could run these. Let's move these over. There we go. Let's move these over to here. Ideally, I don't want them near the silk screen. So, come on, Via. Thank you. I could move them right over, actually, thinking about it. They can come nowhere near that. There we go. There we go. Cool. And then this can go down here. Swish. Yeah, cool. Now I can make that fatter if I need to. Cool. Right, so I'm going to get rid of that connector over there. I'm going to get rid of this one. Let's go back to the schematic. And is that J17, which is this connector here. So let's get rid of this. Yep, tracks, all the lines, that one and that one. There we go. So there's only going to be one. Fine, that should be fine. Yeah, cool. Let's get rid of that, that, and that. Now I've got some space there. I could move these ports up, or I could just leave it blank. Because one thing I haven't accounted for yet is like the feet, like where I'm going to put feet. I could make it almost just like a 3 feet job, so I could put a foot here, foot there, potentially put a foot down here. it's nice when you can have 4, because if you're probing it, you want to be able to have feet to be able to sit on. Could move the programming port down a bit, move the reset button down a bit, and put a foot there. I could potentially, maybe, although it's a bit tight around here, I was thinking move this up, and put a foot there. So it's in the corners. Maybe. Yeah, maybe I should do that. Okay, so I'm going to move this down a bit, fair bit. Okay. I think I had this bigger just because I was trying to get that word in. Oh no, what's happened to that? Let's see if I can do a move group. Move group. There we go. Cool. Let's move the text. Okay, then I can move this thing down. I think that's going to be enough room for a, a screw to be able to go in. I could actually have that master clear come like around this way. Something like that. That looks good. I need a right angle in there. Can I get a right angle? Oh, I don't like it when it does this because it always comes out strange. There we go. Okay, that didn't work. Hang on. Let's go back. I want a right angle. I want this to go up here. So, if I actually do this like this, there we go. There are means and ways of doing this. I'm doing it a slightly cheap way, a slightly ugly way, but you know. Nope. Okay, there we go, and then that can go to there. Let's bring that one down. Bring that all the way out the way of this big V in. Come on. Oh, that's a good point. I better save. There we go. Right. Moving. There we go. Yeah, nice. I think that's better. Got a bit of space now to be able to put potentially a screw in there. To be able to put a foot in. Now, can I move this up a bit? How far can I move it up? That far. And this connector, bring this right up. Just move these things around a little bit. Is that going to be enough space? Don't know. Let's try moving these in here a bit. not ideal that that's running in parallel with that 5-volt rail, but we shall see. Keeps making a little kink down the bottom there, which I don't like. There we go. Ooh, that's weird. Oh, what? Why is that separated there? Strange. Right. Good. Okay, so that should allow me to move this up to here. No, these are nice big data the power lines, which again not ideal. Does that gonna matter? What is that? What bus is that? D. Oh, the D is the LEDs anyway. Don't care. That's fine. Plenty of space there. Yeah, I can move this one up a bit now. That's the DC input. Cool. Then I should have space for a screw there, space for a screw there, space for a screw there. I need to move these around. Actually, would it be sensible to do a big move here? No, I can do it individually. I could do like a group move. I don't want to do that. Okay, that was doing that. There we go. Yeah, cool. Ugh, wow. You go over there. Yeah, up there. Out of the way. Lovely. Resistor. There. That needs to go there. Good, good, good. Happy. Nice. This one. Okay. Okay, hang on. Let's move this into position and then figure that out. So, this looks a little bit ugly, but I might be able to move it and put it on that one instead. There we go. And this one to here. Right, this is nice and ugly now. So, that 5-volt rail needs to get out of there. Yep. This one here can be rerouted. Let's get rid of that. That only needs to be 10th now. No, don't like that. Oh, right, that's why I made it go down to that one. Yes, because it's on the bottom layer. Fine. RB5 looks okay. RB5 doesn't actually need to change to a via there. But it will, because then I can use that 5 volts. That's fine. Let's just get that to look a bit neater. Let's do that, and then do that to get rid of that right angle. And then here, let's put a 24 now onto there. Great. So I think... Oh, let's just move that line there, that 3.3 volt. Ugly. I'm sure there's a mitre tool, isn't there? Somewhere. There is a mitre there, which I think... Let's try it. right? So if I was to do that, if I then do miter, I think I have to set radius. Yeah, there you go. Boop, boop. There's a tool for it. That's nice and easy. Right. Let's do it again. Miter tool. Boop. Cool. That's cool. Right, and there's space there for a screw to hold a foot. So 1, 2, 3, 4. So let's put those in. Let's put them in a circle. The layer I want to put it on is holes. Holes. I want to do is holes or drills. I guess drills. The width of it. Now I've been doing all of this in inches, and now I want to do it in millimeters. Now what did I do the old one on? So, okay. What I'm going to do is I'm just going to pull up another version of Eagle. Okay. And I'm going to bring up a board that I did ages ago and see what size I used for those, because the hole sizes on those were fine. And I'll just copy that. Simple. And so that was the, if I do on this one, file, open a board. Where did I put it? Microchip dev board. Board, that'll do. No, we don't need to open up the schematic as well, that's fine. Has it opened it yet? Is it getting there? Where is it? Let's try that again. Board. Board 2. Yeah, open. Do you also want to load the schematic? No. Okay. It's doing something. Might just be because of all the streaming and stuff. It's just doing it slowly. Okay, I'll tell you what, let's say that we will have the schematic as well and see if that makes much of a difference. Open the board. Board 2, open. Do you want to load the schematic as well? Yes. Nah. Why doesn't it? What? Oh, it did. Did it open it? No. I don't know where it's going. That's the schematic for the new one. No. Oh, that's MATLAB. That's MPLAB. I don't need that. That's the main thing for this. Yeah. See. Yeah. Huh. Fine. Well, okay. Let's just put some drills anyway. I think they were 2.5 2.5 M2.5 M3. I can't remember now. It'd be useful if I had that. Let me just on this screen see if I can open it. Apologies being on the other screen, just in case. Microchip dev board. I know it will open because I've had it open. Now I don't know if that's just done it on the one that I'm running or It's done on the new one. I think it's done it on the one I'm running. I've got 3 versions of Eagle open. Okay, right. These are the holes I'm talking about. Inspect these. Drill 3.5, and this is all in millimeters. 3.5. Fine, so they were M3s. Okay. Fine, in that case then. Let's go back to 3.5. Okay, so circle, drills, width in millimeters, 3.5. No, interesting. Oh, I should be using that one, that's why. .5. Yeah, that's better. Right, so now I want to get these nice and sensible. So they've got plenty of room around them for the head of the screw. Is that going to be enough? There. That'll be fine. And down here. And then over here. Good. Right, so that is all of the holes and things for the screws. The only thing that's left is to do the ground plane. But I'm going to stop here and go and have some lunch. Thank you for watching. See you later.